Let's look at a few examples and see what our type checker should do. And here's a first example where I've got a program with one class definition and an expression. And the expression by itself type checks fine, so if you run this it'll actually be okay. But we're going to do the usual type checking thing of also checking all of the methods and fields in the program, right, in all the class declarations. And if we look at this method, we see, if we look closely enough, there's a problem. Get this x, that's okay, but it apparently returns a number, and when we try to send to it, then we can't do that. So this program should be rejected because x and y fields are not object, even though we're using the result, get x and get y, in a send. Now I've got x and y, I'm using get x and get z. So that's a problem, isn't it? So the posin has no z field. And how do we know we need to look in posin? Well, because we're inside the posin class and we're getting it from this, which implicitly must be an instance of the posin class. Right? So our type checker is going to have to figure that out. How about this one? Alright, we've got a similar sort of problem here. We're using this and get y. This we know is a posin, and we don't see either here or in a superclass a get y. There is no field, there's no method rather, called get y, and so this has to be rejected. How about this one? Let's see, we've got get this x, get this y, plus, that all looks fine this time. But look at my declared type for mdist, num arrow posin. We're not using arguments, so num is fine there, but we don't return a posin, do we? So we need to not only type check the body, but we need to make sure it's consistent with the declared type, because any calls to the method are going to use this declared type. So if we change that to num, that's the only change I made. Is this okay? Yep, looks great for a change. X and y both exist. They're both numbers. We can add them. We're returning a number as we should, and everything's fine. Okay, how about if I change the program by replacing the 10 with new posin 12? Of course, 12 is not enough arguments, so our type checker will need to look up the class posin and see how many fields it has. And besides looking up how many fields it has, what's wrong with this program? This new posin looks okay because it's a number and a number corresponding to the fields, but this produces a posin, not a number, right? We can't have an object going where a number would want, because if we did that, we might eventually get an error here, not a number error. So we have to rule that out. We have to check the number and the types of fields provided to new. I've added a new method here, clone. Okay, and it says it takes a number and returns a posin. I've got a new posin. Get this x and get this y. I'm calling it. Well, this all looks fine, right? So yes, indeed, this is fine. We're using posin as both a class name and as a type name. How about if we extend it with posin 3D, instantiate new posin 3D? Does that look okay? We've got the right number of fields here. And I've got mdist, which takes a num and returns a num. It gets the z field of this. That'll be okay. And it has a supercall. Is this supercall okay? Yes, because the superclass posin has an mdist, it takes a num and returns a num. And we're providing it one argument, which is a num according to this type. So all that's good. What if I change it so that mdist returns new posin 1010? Locally, this is fine. Mdist takes a number and returns a posin, and this produces a posin. But the problem is, if I take this new posin and call mdist, it's different from taking a posin as opposed to a posin 3D. Right? And we don't want to be able to change the result type of a method when we make a subclass, because as we'll see, someone using a posin 3D may think they just have a posin. Right? So if I change clone to take num and return a num, again, that's not okay. It changes the result type. What if I have clone here? I have to keep the type the same, but I return a posin 3D. Is that okay? Well, anywhere you wanted a posin, you should be able to use a posin 3D, because it extends posin, which means it has all of the same fields and all of the same methods. So, in fact, we're going to say this is fine, but that's going to mean that we need subtypes. We need to treat subclasses, as we use them as types, as subtypes of the superclass. So to summarize, our type checker will need to do all these things. It will need to use class names as types. Check for field and method existence when you have a get or a send. Check field method and argument types. When you call a method, look up the method's result type, or when you extract a field, look at the field's type. And similarly, inside a method, make sure the body expression has the right type. We'll need to check fields against the fields of a class against the arguments provided in U, both in terms of count and the types of the fields. Make sure that overriding methods don't change the types and on arguments and results, and also treat subclasses as subtypes so that we have the kind of subtyping flexibility that you expect.